All right, in this video, I'm going to show a couple of tricks and tips that you can use when using substitution as a method to solve a system of equations. So here we have two equations, w equals k plus 3 and w plus k equals 11. And we're trying to find out the values of w and k. All right, the first thing that I would look for when using the substitution method is look to see if one of the equations already has one of the variables isolated. In this case, w is isolated in one of the equations. So let's use that. That's really helpful because all we need to do now is, what I would do is put parentheses around what w is equal to. That parentheses is a really good visual way of saying w is the same thing as this package over here. And so packages are really easy to visualize when we are substituting for a particular variable. So let's turn to our second equation here. Do you see that we have w here? Well, we want to substitute out that w and put in k plus 3 in its place. So we are going to write this bottom equation here so that w is taken out and k plus 3 is replaced with that w. So the only variables that we're going to have in this bottom equation when we're done with it will be just k. So let's take out this w and let's put in x plus 3 in its place. And then it's plus k equals 11. So now we have k plus 3 plus k equals 11. Let's combine like terms. So k plus k is 2k plus 3 equals 11. Let's subtract 3 from both sides. So that's 2k equals 8. Or you divide then everything by 2 and you get k equals 4. All right, so we know now that k equals 4. In order to find out what w is, what I would suggest is, while you can plug 4 in for k either here or here, wouldn't it be easier to solve for w when w is already isolated? So what I would do is, I would plug k in, or 4 in for k in this top equation. So w equals k, which we now know is 4, so it's 4 plus 3, and w equals 7. So I think that is one of the easier ways to do the substitution method here. There are many ways to do it. You would have gotten k equals 4 and w equals 7 if you had substituted using other ways, but I think this was the easiest way to go about it. Okay, here's another example. What if we have r minus h equals 1, and we have h equals 11 minus r? So here, using the substitution method, do you see that we already have h being alone here? So let's use that. Remember, let's put our parentheses around it so we have this package is equal to h. Okay, so then it's easier to visually substitute. So now, here we have r minus h equals 1. Let's substitute out h. Let's pull h out and put in what it is equal to, which is 11 minus r. So it's going to be r minus, just like I'm just rewriting this here, r minus h. What is h equal to? This package. So here we go. So it's 11 minus r. And then we finish up the equation, equals 1. The reason why the parentheses is so helpful is because now we understand that we are going to have to distribute this negative over every single thing within the parentheses. If we didn't have the parentheses there, we would have forgotten to distribute this negative over everything in here, which is crucial. So here we have r negative times 11 is negative 11, and then negative times negative r is positive r. That's really important to distribute that negative. equals 1. Now we can combine like terms, so r plus r is 2r, and we have 2r minus 11 equals 1. Now we add 11 to both sides, and we get 2r equals 12. Then we can divide both sides by 2, and 12 divided by 2 is 6. So r equals 6. Now, to figure out what h is, we could plug 6 in for r here, or 6 in for r here. Don't you think it would be easier to plug 6 in for r here because we already have h by itself? So let's use this bottom equation. Not that you couldn't use the top one, but because it's so much simpler to use this bottom equation, let's do that. So h equals 11 minus r, which we now know is 6. So 11 minus 6 is 5. So now we know that h equals 5. Now remember, because we don't know whether r is supposed to be the x variable, meaning the independent variable, or whether h is supposed to be the dependent variable, meaning like the y variable usually. Since we don't know that, we can't put it like in a coordinate form, like 6 comma 5 or 5 comma 6. We can't do that. This is as much as we can do, and that's perfectly fine. Okay. So now for the last example that I'd like to use as sort of a tip is, let's say that we have a more complicated equations, a system of equations, meaning we've got neither v or p completely by itself. So here's our first equation, and here is our second equation. And we are solving for v and p. Okay, unfortunately, neither of these equations have a variable completely by itself. So that means we need to algebraically manipulate an equation, one of the equations, so that one of the variables is by itself. It doesn't matter which variable gets by itself, v or p, but you just need to get one of them by itself so that you can plug it into the other equation. So let's strategize on which variable would be the best variable to try to get to be alone. So you might look at this and you might say, 5v. It's almost alone already. All you have to do is divide everything by 5. Okay, I'm not saying you can't do this. I'm just saying if you do this, you'll make your life a little bit more difficult. So if you divide everything by 5, which you can do, then the 5's cancel out and you just have v. Okay, that's fine, but then look at this. Now you have 3p over 5 plus 2/5. That's a lot of fractions to work with. So I would suggest not doing it that way. What I would suggest is actually keeping this equation completely how it was originally. Okay? So I would actually keep this how it is. Let's look at this equation. 4v minus 2p equals 4. Okay, do you see that if I divide everything by 2, that this 2 and 2 will drop out and I'll just get p alone, okay? So I would actually suggest that you try to use this equation to isolate p. Again, it's not the only correct way to do it. I'm just thinking that it might be a little bit easier to do it that way. So what if we subtracted 4v from both sides, and then we have minus 2p equals 4 minus 4v, and then now we have negative 2 times p. So let's divide everything by negative 2 to get p alone. So negative 2 is going to divide into everything. So then negative 2 over negative 2, that just leaves us with p here. 4 over negative 2, 4 divided by negative 2 is negative 2. And then we have negative 4v divided by negative 2. And negative over negative cancel out to be a positive. And then you have a 4 divided by a 2, which is 2. So this turns out to be 2v. So p equals negative 2 plus 2v. Do you see that there are no fractions here? If there's no fractions, it's going to be much easier to substitute back in. So now I'm going to just write this up here so we have more room. So P equals -2 plus 2v. By the way, another way to write this is, since these two things are being added together, you could write P equals 2v minus 2. In fact, let's use that one. They're all correct, but this one seems to be the easiest to work with. Okay, so now we have isolated P by itself equals 2v minus 2. What I would do is always put parentheses around this to make it into a package so that you can substitute it later more easily. And now let's put it into this other equation. All right, so now we have 5v equals 3 times p. But remember, p is equal to the package 2v minus 2. And p is equal to this package, so it's 3 times p, and p in this case is 2v minus 2. So it's 3 times p, but this package is now in place of p, okay? And then plus 2. All right, now it's 5v equals, do you see that we have this parentheses, which reminds us to distribute this 3 over everything, so that's 6v, and then 3 times -2 is -6, and then plus 2 over here. So it's 5v equals 6v, and -6 plus 2 is a -4, like that. And now what we can do is we're going to subtract 6v from both sides. So let's subtract 6v here, 6v here. All right. So 5v minus 6v is -1v, all right, equals -4 over here. Now I divide both sides by -1, and I get v equals -4 divided by -1 is a +4. So v equals 4. All right, so I can write that over here. V equals 4. Now that I found out what v equals, I can plug 4 back in for v anywhere I like to figure out what p is. Now here's this other tip. Yes, you could plug 4 in for v here or here, but wouldn't it be much easier to plug v in one of these equations, because p is already isolated? So what I would do is not plug 4 in for v here, but I would plug 4 in for v in one of these equations because we already have p isolated. You can use any of the equations that you've created to plug back into. So let's use this one right here. So if p equals 2v minus 2, and we now know that v is 4, that's p equals 2 times 4 minus 2. So p equals 8 minus 2. 8 minus 2 is 6, so p equals 6. So now we know that p equals 6 and v equals 4, and we have found the numbers that each of these variables are equal to.